to my channel. My name is PrachiSharma and this channel is about learning chemistry for 10th grade ICSE. So if you are struggling with chemistry right now, this is the best place to stop by and go ahead and check out the channel for more videos. Today's session is on mind mapping of sulfuric acid. What is a mind map? It's a consolidated format of making notes so that during the exam it's easier for you to go through more chapters in less time, and revision of the theoretical portion is faster and you can spend more time on the questions part. So going through a mind map reduces your time for theoretical revision from the book, in which you're going through more portion but not able to touch base with the most important parts of it. So when you go through this entire video, make sure that you leave a feedback in the comment section and let me know what were your thoughts on this way of revision. If you like it, I would definitely go ahead and make more videos on a similar pattern for before your examination starts. We can go through more chapters in a similar format and it would be easier for you to get by. Now you can download the notes from the description box, or you can join the Telegram channel in which I post the notes after every video, so you directly get it on your phone without getting through the hassle of downloading them. So you can connect on the Telegram channel also. So without wasting any time, let's get started with the understanding of roadmap of sulfuric acid. Alright, my dear students, I hope you can clearly see the mind map for sulfuric acid on the screen. Let's take a few minutes and understand how this is formatted out, how it is made out. So I have 2 pages for sulfuric acid. The first one is about the different properties that sulfuric acid is showing and a few examples from each one of them, and the equations, the most important equations that you need to learn for this particular chapter. The second page is on contact process. So this contains all the steps for contact process and any particular notes or reasoning question that might show up. The third page is just the diagram of contact process for reference. So if you download this and get a printout for these, or you can make it on your own, then this is extremely sufficient for the preparation of sulfuric acid. You do not need to check out anything else from the book. This contains end-to-end everything from the chapter. So let's get started. So for going through the video, I'll zoom in every column and then we discuss about it. So let's get started with the section first part. So you have sulfuric acid. The formula is H2SO4, also known as oil of vitriol. The structure is S, 2 of the lone paired O and O, you can see, then OH with single bonds, you can see that. Now let's start with the first property. So the first property is the acidic property of dilute acid. So for sulfuric acid, you go through 2 types of properties. One is dilute acid properties and another is concentrated sulfuric acid properties. If they ask you a question, that is, what is the difference between concentrated sulfuric acid and dilute sulfuric acid, you can mention these properties in that as well. So let's get started with the dilute acidic property. So I'm starting right here. So in dilute acidic property, there are 3 to 4 different types that they have mentioned. In dilute acidic property, if your dilute sulfuric acid reacts with metals, that is magnesium, zinc or iron, it gives you FeSO4 or ZnSO4 or MgSO4. Along with that, it gives you hydrogen gas. So you have to remember what is in the products coming out. So if dilute sulfuric acid is reacting with sulfuric acid, it ends up giving you hydrogen gas. If it is reacting with metal oxides, it ends up giving you salt and water. That means if you have metallic oxides or hydroxides, you get a neutralization reaction happening in which you get salt plus water. Another important thing here is that if you have carbonates or bicarbonates, so carbonates is CO3, so Na2CO3, CuCO3, NaHCO3 or KHSCO3. So this is carbonates or bicarbonates. So if that is happening, in that case you get carbon dioxide gas along with salt and water. So always remember them in a certain pattern. If H2SO4 is reacting with metal, it gives you hydrogen gas. If it is reacting with metal oxide or hydroxide, the hydrogen gas converts into water. If you have carbonates or bicarbonates, along with salt and water, you have carbon dioxide gas coming. Then after that, if you have Na2S, that is sulfides, then you get hydrogen sulfide gas. If you have Na2SO3, that is sulfides, so in that you get SO2. So sulfides or bisulfides, you get SO2 gas. Okay, so I hope this makes sense to you. Always remember them in a certain pattern. Always remember the examples, the easiest ones, remember them at examples, and try to learn equations with a basic concept that what is exactly happening. Okay, now let's move on to the next one. So the next is non-volatile nature. So non-volatile nature is of concentrated acid. So since since H2SO4 has a high boiling point, that is 338 degrees Celsius, therefore it is non-volatile. And since it is non-volatile, it is used in the preparation of less volatile acids, so such as you have HCl acid, that is hydrochloric acid, nitric acid, acetic acid. So it is used in that preparation. The two equations that you have in the syllabus for this is, so your HCl can be formed either from NaCl, that is also preparation of hydrochloric acid, you can write that directly, or you can also use KCl. So KCl or NaCl reacting with H2SO4 giving you NaHSO4 plus HCl gas. Then you have NaNO3 or KNO3, depending on which one you want to remember. One of them you have to learn. That gives you NaHSO4 plus HNO3. So if you basically think about this is not anything additional that you have to learn. If you have done HCl and nitric acid chapters separately, you would know their preparation reaction. So you can directly use those preparation reactions, which is the same thing. Now, moving on to the next property, we have as oxidizing agent, that is for concentrated acid. So as oxidizing agent, so why is it a good oxidizing agent? This is a reasoning question. So on thermal decomposition of H2SO4, you get nascent oxygen. Then with nascent oxygen, you can remember three examples. Carbon, sulfur, copper. All three of them get oxidized by sulfuric acid. The examples are given here. C plus H2SO4 gives CO2 plus water plus SO2. S plus H2SO4 gives SO2 plus water. Cu plus H2SO4 gives you CuSO4 plus H2O plus SO2. Okay. Now, next is your as a dehydrating agent as a concentrated acid. So H2SO4 has a great affinity for water. So it has a high tendency to pull out water. That is the reason it is known as dehydrating agent. Now, this is a copper salt, that is CuSO4.5H2O. So this is water of crystallization. Now H2SO4 has a high tendency to pull out that water. And when that happens, the blue color of CuSO4.5H2O turns to white and water is given out. Okay. Similarly, you have examples for glucose and sugar. So C6H12O6 gives you 6C plus 6H2O. Another one is your sugar, C12H22O11 giving you 12C plus 11H2O. This 12C is your sugar charcoal. Okay. And this is a black spongy mass. So what happens is that when H2SO4 pulls out water, the black spongy mass, the water comes out at steam. What is left out is a black spongy mass of carbon. And this gets heated up because it's an exothermic reaction. And when that happens, it is said that it is charred. So for example, if you have H2SO4 dropped on your skin, it can pull out water from your skin, leaves a black spongy mass colored, you can say, stain on the skin. So what is the color of our skin if H2SO4 is dropped on our skin? It turns black, and it is also known as charred skin. Okay, CHARED, charred skin. This is the word that you have to remember. Okay. Now let's move on to the next one. Now these are the tests for sulfuric acid. There are three particular tests for sulfuric acid. The first one is with barium chloride. You have barium chloride reacting H2SO4, you get BaSO4, which is a white PPT, and this white PPT is insoluble in mineral acids. Why do you have to remember additional information? This is for confirmation that you have HCl gas, or this is a test for sulfuric acid. So you have to confirm that in the exam. They can ask you, how can you confirm this particular product? So the first question would be, XYZ reactions are happening. What is the product coming out? So you tell them, okay, it's BaSO4, which is a white PPT. Second question would be, how will you confirm these products? So for confirmation purpose, you need additional information for that particular product. So in this case, if you're confirming BaSO4, you will say that it is insoluble in mineral acids like HCl and HNO3. Okay, makes sense? Then moving on, another thing is that barium sulfate and barium sulfite, both of them are white in color. But barium sulfite is soluble in mineral acids, but barium sulfate is not. So if they ask you what is the difference between barium sulfate and barium sulfite, although both of them are white in color, then this would be your answer. That one of them is soluble in mineral acids, other one is not. Then the next one you have is copper with H2SO4. This gives you a gas that is SO2. Okay, so this is your test, that if you're reacting sulfuric acid with copper, you get a gas which turns acidified potassium dichromate paper from green from orange. So it turns it green from orange. So this is your confirmation for the gas. Then the third is NaCl plus H2SO4 give you NaHSO4 plus HCl gas. So HCl gas, that is pungent fumes. How will you confirm it? This is HCl gas. You can use any of the tests of HCl gas. The most common one is ammonium hydroxide. It comes near that and you get white fumes. So that is the most common test for HCl gas. So pungent fumes are there. That is for HCl. Okay. So this is the first part of it. In this section, we have done everything that is related to the properties of sulfuric acid. The next is your contact process. Contact process is very important. The way this page is written out is that you have step 1, step 2 going like this, then step 5 coming down. So going like this and then coming down. And after that, we look at any conditions or notes that we need to know. So the first step is production of SO2, production of sulfur dioxide. So in sulfur dioxide, when it is prepared, you have iron pyrites reacting with oxygen, giving you Fe2O3 and SO2. Or another formation that you can use for SO2 is S plus O2 gives SO2, and this is Louisiana sulfur, which is 99.5% pure sulfur. Okay, so you can use any of these equations. Then step 2 is purification of gases. So why do we need to purify these gases? The main reason for purification is that if there is any impurities present, they can poison your catalyst and reduce the efficiency of the entire production of sulfuric acid. So if the catalyst gets poisoned, there is no point of having the catalyst if it cannot speed up the reaction. So if not purified, catalyst loses efficiency. This is the reason for purification. Now how is the purification happening? You have the mixture, that is your SO2 and air, regular air. This is gone through, you pass this through electric precipitator in which you have high electric potential. And due to the high charges present in that, you can get rid of any solid particles that are present as impurities in the mixture. So minus solid particles in this step. Then it goes through a water scrubber. In water scrubber, the dust particles come out. After that, you move to arsenic purifier. In arsenic purifier, you get minus arsenic oxide. So the dash that you see is of a minus sign. So minus solid particles, minus dust particles, minus arsenic oxide. Okay, so this is your purification of gases. The third step is, now since the purification has happened, now is the point where the mixture will enter into the catalyst zone. The reaction will start working. So catalytic oxidation of SO2. So SO2, you're turning SO2 into SO3. That is your target. Okay. So SO2 plus air plus vanadium pentoxide or platinum. These are the catalysts that you're using in the process. So SO2 plus air plus vanadium pentoxide or platinum in the contact tower. Okay, so in the contact tower is where your catalytic oxidation is happening, and that is the reason this process is known as contact process. Now, when you are going through the contact tower, catalyst is placed in vertical iron pipes inside a cylindrical iron tower called the converter. Okay, so where is the catalyst placed? If they ask a question, where is the catalyst placed in contact process? So it is placed in the converter and in cylindrical iron tower. What is the equation for it? That is SO2 plus oxygen in the presence of V2O5, that is vanadium pentoxide. The temperature is 450 degrees Celsius, giving you sulfur trioxide, that is SO3 plus heat. Now, since this entire process, this entire reaction is exothermic, so you only have to give it heat in the initial phase. Once you have given the heat, the reaction will automatically maintain the temperature of it since it is exothermic. So you don't have to consistently give it more heat. So the temperature is maintained by the heat evolved during the reaction. Okay, so this is step 3. How far are we? What have we done? We have done the production of SO2, then we purified the gases, then we catalytically oxidized SO2. Now, step 4 is gas is cooled. Of course, it's an exothermic reaction. So when the temperature has gone high, now you will cool it down. So gas is cooled in the absorption tower, where you have concentrated H2SO4 98% pure. So you have SO3 plus H2SO4 giving you H2S2O7, which is known as oleum or pyrosulfuric acid. Okay. Then next step 5 is dilution of oleum. So oleum that you have got is 98% pure. Now from this you start adding up water in calculated amount, that is depending on the strength of H2SO4 that you need. So once you cool it down, then you move to step 5, in which you are diluting it by adding water in it. So what is the way that you add water in it? So dilution tank. In the dilution tank, you will have calculated water added to get desired strength of sulfuric acid. So what do you have here? You have pyrosulfuric acid, you have water added to it, and you're getting H2SO4 of the strength that you need it to be. Now, this is the entire process of contact process. So step 1, step 2, step 3, step 4, step 5. So you can go through that once in your brain. That is, the first is your production of SO2, then purification, then catalytic oxidation, then gas is cooled, and then you add water to it. Okay, 5 steps, 5 simple steps. And then for every step you can go through the details from the mind map. This is a mind map. Then let's come on the favorable conditions for contact process. So if you look here, these are the favorable conditions. You have 4 favorable conditions. The first is exothermic reaction are favored at low temperatures. So the good temperature to maintain for contact process is 410 to 450 degrees Celsius. Then you need to maintain high pressure, but there is a reason there. Since, okay, I'll come to the reason later. So high pressure that you have to maintain here is 1 to 2 atmosphere. Then excess of oxygen. Excess of oxygen, this arrow means increases the production of SO3. So increases the production of SO3. So excess of oxygen increases the production of SO3. Then a suitable catalyst, you have vanadium pentoxide or platinum. So these are the 4 favorable conditions for you that you have to remember for contact process. Now, you have certain notes that these questions can be asked in reasoning. All 3 of them. So the first is SO3 does not dissolve in water and gives heat and droplets of sulfuric acid. Therefore, it is not directly absorbed by water, and that is the reason why we first convert into pyrosulfuric acid and then we add water to it. Okay, so what is the reason? SO3 does not dissolve in water sufficiently and it gives out heat and droplets of sulfuric acid. Therefore, it is not directly absorbed by water. Okay, the second important one is high pressure. So high pressure favors the reaction. Therefore, the product formed has less, because the product formed has less volume than the reactant. This is because. So high pressure favors the reaction because the product formed has less volume than reactant. But the acid resistant towers are difficult to build. Therefore, we maintain the pressure at 1 to 2 atm. Okay, students, I hope that makes sense. So high pressure is favoring it, but what happens is the product formed has less volume than reactant, and acid resistant towers are difficult to build. So two important key points. These are your key points that you have to keep in mind. Then the third important point is platinum is more efficient, but instead we use vanadium. We always prefer vanadium because platinum is more expensive and it is easily poisoned by arsenic oxide. Therefore, we prefer vanadium pentoxide. Okay, so this is your entire contact process. Now, I have just attached the diagram of contact process for reference, but they won't ask you to draw the diagram or anything. And if you understand the basic working of contact process, the diagram would be easier for you to understand. So that would be it for these are the mind maps, and you can download this from the description box. So, my dear students, this is it for today's session. I am 100% sure that this mind mapping method would 100% benefit you during your examination. So, make sure that you leave a feedback in the comment section and let me know what are your thoughts on this method of revision. So, thank you so much. We'll catch up on the next session. Make sure that you like, share, and subscribe this channel with your friends and family and help us move forward. Thank you. I'll see you in the next one.